prove that cos inverse of 4 by 5 plus cos inverse of 12 by 13 is equal to cos inverse of 33 by 65. We have to prove this LHS is equal, this is LHS is equal to this RHS. LHS means left hand side, RHS means right hand side. So answer row. First take this LHS. LHS is equal to, take this cos inverse of 4 by 5. Don't take that. Take this as A. So let A is equal to this cos inverse of 4 by 5. Now this is inverse, shift to this side. Then this cos, when cos inverse is moved to this side, cos inverse will become cos and A will be as it is equal to, this is already moved to this side and it became cos, and this right as it is 4 by 5. Okay. Now we have a formula, sin A is equal to square root of 1 minus cos square A. So using this formula you can find the sin A. Substitute 1 minus cos A. Cos A means this 4 by 5. But square is there, so whole square. So this is sin A. Again that is equal to square root of 1 minus, square is applicable to 4 and 5 separately. So 4 square divided by this 5 square. Simplification, sin A is equal to square root of 1 minus, so 4 square means 4 into 4 16, 5 square means 5 into 5 25. That is equal to again square root of, now we have to take LCM. Here nothing is there means 1 is there. So since it is 1, so whatever the number is here, that will be the LCM. So write like this 25. So divide this 25 by this 1. This is denominator, this is numerator. 25 by this 1 will get 25 only. You multiply that 25 with this numerator 1. So 1 into 25 is 25. Minus, next divide this 25 by this 25 denominator. So 25 by 25 you will get 1. So that multiply that 1 into 1 with this 16 numerator. So 1 into 16 is 16. Next square root 25 minus 16, how much? 9. So this 25 keep as it is. Next to square root 2. Okay. So 9 we can write as 3 square. Because 3 square is 3 into 3. 3 into 3 is 9. So 25 can be written as 5 square. Now we can split the square root for this separately like this. Square root of 3 square divided by square root of 5 square. That is equal to, so square root cancels, square root cancels. What is left? 3 by this 5. So we got sin A is equal to 3 by 5. So remaining part I will solve back side of the board. Just a minute, I will take a pen. So we have got sin A is equal to 3 by 5. Next we have other thing. This one, cos inverse of 12 by 13. I will take this as B. So let B is equal to cos inverse of 12 by 13. Now shift this cos inverse to this side. When cos inverse is moved this side, it will become cos. B will be there only, is equal to 12 by 13. You write as it is. Okay, we got cos B is equal to 12 by 13. Next we have a formula, sin B is equal to square root of 1 minus cos square B. So substitute square root as it is 1 minus. So cos B is 12 by 13. Okay, but this square is the square. Next square root to write as it is 1 minus. Okay, square is applicable by this 12. So 12 square divided by next 13 this square. Next square root 1 minus 12 square means 144. 13 square means 169. Next I will write here. So sin B is equal to square root, this square root 1 minus, no, square root I have taken. See here nothing is there means 1 is there. Since this is 1, so LCM of this and this is this only, this number. When this is 1, any one of these two is 1, LCM will be multiplication of this and this. So 1 into 169 will get 169. Right here 169. Next take this is denominator, this is numerator. Divide this 169 by this one. So you will get 169 only. 169 divided by 1 is 169. So multiply that 169 with this 1 numerator. So 1 into 169 will get 169 only. Next to minus you keep as it is. Next divide this 169 by this 169. So we will get 1. Multiply that 1 with this 144. 1 into 144. So 144 only. Next step square root of 169 minus 144. How much? 169 minus 144. So we get 25. So this 169 I write as it is. Split this square root for this and this separately like this. Square root of 25 by square root of 169. Okay. Square root of 25 is 5 and square root of 169 is 13. So sin B is equal to this pi by 13. Pi by 13. Okay, remaining I will solve here only. So in the back side of the board we have seen LHS is equal to cos inverse of 4 by 5 plus cos inverse of 12 by 13, right? So this we have taken A plus this we have taken as B, A plus B. So next you remember this one, sin B is what? Next we have to use the formula. I will show that. So I just erased one thing. This I took B, right? So B is equal to this. When B is equal to this, like this I showed, right? B is equal to cos inverse of 12 by 13. And this is moved to this side. So So what you will get? Cos B is equal to 12 by 13. Okay. So this you have to remember. Next we have a formula cos A plus B is equal to, so these two things I will write here on the top. Okay, cos B is equal to 12 by 13. Sin B is equal to 5 by 13. So I will just erase this. We have a formula, this you have to remember, cos A cos B minus sin A sin B. So that is equal to cos A. Cos A is what? See, cos A is 4 by 5. Nothing is there means into is there. Cos B is this 12 by 13. So next minus sin A. Sin A is how much? See, sin A is equal to, we got this 3 by 5. We simplified. See, 3 by 5. Sin A is 3 by 5. Nothing is there means into sin B is this 5 by 13. Next to one second. So multiply these two separately, numerators multiply this. So 4 into 12 so 48, 5 into 13 65. Next to minus, multiply these two, 3 into 5 15, 5 into 13 65. So 65 65. See, this is denominator, the numerator, denominator numerator. So denominator same. So when denominators are same, you write denominator 65 once. Next to whatever is there, you write it here. So 48 minus 15. So 48 minus 15. 3 3. How much you got? 33. 33, this 65. So we got cos A plus B is equal to 33 by 65. Next I will show here. Next to, so I want A plus B. So I will move this cos to this side. So what will happen? A plus B keep as it is. So when cos is moved this side, it will become cos inverse 33 by 65. 33 by 65. Now what is A? See here. A we have taken this. A means this cos inverse of 4 by 5. Substitute back. Plus B. What is B? B means this cos inverse of 12 by 13. Okay. So that is equal to this cos inverse of 33 by 65. So we got cos inverse of 4 by 5 plus cos inverse of 12 by 13 is equal to cos inverse of 33 by 65. So now you see the question. See, cos inverse of 4 by 5 is equal to this. Cos inverse of 12 by 13 is equal to cos inverse of 33 by 65. That means we have proved it. LHS is equal to RHS. Whatever they have given, we have to prove this. Same thing we got here. See, we got same thing. That means we proved the identity. So the problem is solved. Okay. That's all. Thank you. Subscribe.